What's up, everybody? This is Sean Woleslagle, Cybersecurity, and today I am going to be working through some Python basics. Yes, I'm going to go ahead and work through some Python because I am pretty rusty at it, and I need to get some sharpening down on my skills. So, I'm just going to go ahead and call this video series The Road to Red Team, and this will be part one of that. I'm working on, I'd like to become a red teamer at some point, and right now I'm very blue team, and so part of that journey involves Python. So today I just felt like doing some Python. So let's dig in here. I'm on TryHackMe, and this is just one of the rooms here on TryHackMe. So without further ado, let's go ahead and dig into this a little bit. So Python Basics. Introduction to Python. In this room you will get hands-on with and learn about the scripting programming language Python. Although programming isn't required to succeed in security, it's a great skill to have. Yes, it is. Definitely it is. As the Scripting for Pen Testers module demonstrates, being able to program allows you to create security tools and create quick scripts that will aid you in hacking as well as defending and analyzing. This room will teach you variables, loops, functions, data structures, if statements, files. You'll be using the code editor on the right-hand side to complete exercises and solve challenges. This room will teach you the basics just enough to give you the knowledge to make your basic scripts. If you want to use your development environment to code, download Python on the official website, which gives you an IDE to code in. In programming, syntax is important as it describes the structure of a valid programming language. In simple terms, syntax tells the computer how to read code using rules that control the structure of symbols, punctuation, and words of a programming language. Answer the question below. Run what's currently in the code editor by clicking the green Run Code button on the right-hand side of the screen and move on to the next task. Okay, sounds easy enough. I think I can do that. Disclaimer, I do have Python background, although, like I said, I'm pretty rusty, so we'll see where I go with this and how much I remember and go from there. So, hit the run code like it asked me to, and yeah, you can see here, it printed, learn security with TryHackMe, pretty basic. Usually you get a hello world, and this time it just says learn security with TryHackMe. Sounds good. We'll hit the completed on that, and alright, we've started a streak. Very cool. Alright, I guess next is hello world. Okay, so it wants us to create that. Okay, so task number 2. To begin, let's create a simple program that outputs some text. As you can see from the example code block above, it's just one line, shown on line 2, and when we run this code, it will output the text, hello world. Let's break this down. In the example, line 1 is a comment, a line starting with a hashtag symbol and is not run by the computer. A comment is written by the programmer, you, to help other people reading the code understand what is going on. We can control what is output to the screen by using the print statement. Anything inside of the parentheses will be output. However, because we are printing a string, more on data types later in the room, we have to put them inside of quotations. Please note this room's examples are for Python 3. Okay, so I guess we just start it this way and print hello world. Just the way they have it. Let's see what happens. See that? We got a flag. Pretty cool. Copy that guy. We'll paste that. Submit it. And we got it right. Pretty easy so far. Alright, digging into some math. Let's now cover mathematical operators and how they can be applied to Python. Like a calculator, there are operations such as adding, subtracting, multiplying, and dividing. Using Python, we can code our calculator. After all, programming is just writing rules for the computer to follow given specific inputs and conditions. The table below shows the different operations. We have our operators. I'll say this for people who don't know anything about programming. This one's a weird one, modulus. We know our basics, addition, the PEMDAS, addition, subtraction, multiplication, division. And if you're not from America, you don't know what PEMDAS is. It's please excuse my dear Aunt Sally. It's our order of operations, right? And so modulus is what is left over. So 10 divided by 2 is 0. Modulo 2 is 0 because there wouldn't be any remainder. But if it was like modulo 3, I don't know off the top of my head, to be honest. So I'd have to run that and see what it would get. Math isn't my strong suit, but that's okay. That's what the beauty of computers is for, because you can just do math that way. And I wish I was better at math, but that's okay. Exponents, so 5 to the power of 2 is 25. Now that we know basic mathematical operators, let's move on to comparison operators. These play a big part in Python, and will be built upon when we look at loops and if statements. These operators are used to evaluate a program's condition at a particular state. Greater than, less than, equal to, not equal to, greater than or equal to, and less than or equal. In the code editor, print the result of 21 plus 43. What is the flag? Okay, easy enough. Do a space there. Print 21 plus 43. Let's get it. What is the flag? Did I do something wrong here? Maybe I just want to not have this in here. Yeah, that was the issue. Okay. Cool. Addition. Good to know for future reference. All right, now we'll just take this out, and we'll say 142 minus 52. Run code. I definitely encourage you to do this along with me if you're into this kind of stuff. If you're into cybersecurity and you're into programming, I think it'd be useful to do it together. And I think that if you want to connect up with me on locals and we can work on some things together, that'd be great. Multiplication. Okay. The result of 5 squared. What is the flag? Squared. See, I told you math isn't my strong suit. Exponent power. But that's okay. I admit that math isn't my strong suit, and I'm okay with that because I can always improve. Variables allow you to store and update data in a computer program. You have a variable name and store data to that name. So, example they give is food is equal to ice cream and money is equal to 2,000. Or I guess the proper way to say it is food is ice cream and money is 2,000. In the example above, we have two variables. The variable name, food, stores the string words, ice cream, while another variable called money stores a number 2,000. Variables are powerful as you can change them throughout your program. The following example sets the age variable to 30. Then we increase this age variable by 1, making the final variable data 31. Feel free to copy and paste this into the editor, run the code, and see its output. All right, let's do that. Let's take a look. Delete that line. Yeah, so age is 30, then age is age plus 1, so we take age plus 1, 30, and then print the age, so 31. That makes total sense. Not to jump the gun, but you can also do plus equals, which is really cool. We'll get there, I'm sure. I'm sure they're going to teach us that. Notice on line 2, the way we update a variable on the left, and we have the already created variable name age, followed by the equal operator. On the right, we have what we're setting the variable to. In our case, the age variable, which is currently set to 30. is being increased by 1. Let's talk about data types, which is the type of data being stored in a variable. You can store text or numbers and many other types. The data types to know are strings, used for combination of characters such as letters or symbols, integers, whole numbers, floats, numbers that contain decimal points or 4 fractions, booleans, used for data that is restricted to or true or false options, and lists, a series of different data types stored in a collection. So we have strings, like this, floats, you see the decimals, integers times viewed, okay, so normal integers, favorites, true, false, false, lists, seen by Alice and Bob, Charlie, Daniel, and Evie. In code editor, create a variable called height and set its initial value to 200. Okay, height is equal to 200. All right, on a new line, add 50 to the height variable. Okay. So again, I could have just said plus equals 50 and that would have been fine. So just to show you what that looks like, I could do this if I wanted to, and that would do the same thing. But just because we're going to take our baby steps here, we're going to do it the way that TryHackMe wants us to do it. All right, completed. Let's just run the code to make sure that I don't. I guess I can't run it yet because I don't have it printed. Okay. Let's print out the value. Print height. Okay. There we go. And we get our variable, which is 250. And let's just say, for the sake of this, I'm just curious if it would still give me the same answer. Yeah. So exactly what we expect. If I run the code, it does the same thing. Perfect. And we're just going to leave it like that because I like this better. It's easier for me to read. Okay. Logical and Boolean operators. Logical operators allow assignment and comparison to be made and are used in conditional testing such as if statements. Logical operation, operator, and example. So equivalence. So this is equal, right? Less than, if x is less than 5. If less is x than or equal to, greater than, and greater than or equal to. Okay. So Boolean operators are used to connect and compare relationships between statements, like an if statement. Conditions can be true or false. Super powerful for whenever we go to start building loops and things like that. Both conditions must be true for the statement to be true. And so if x is greater than or equal to 5 and x is less than or equal to 100, it returns true if x is a number between 5 and 100. Only one condition of the statement needs to be true, or if x is equal to 1 or x is equal to 10, return true if x is 1 or 10. If a condition is the opposite of an argument, not. If not, y. Returns true if the value is false. Let's look at a few Python code examples. A is 1 if a is equal to 1 or a is greater than 10. Print a is either 1 or above 10. Name is Bob. Hungry is true. If name is equal to Bob and hungry is equal to true, print Bob is hungry. Else, if name is equal to Bob and not hungry, print Bob is not hungry. Else, if all other conditions are not met, print not sure who this is or if they are hungry. Alright, so let's just take a second here. I know it doesn't say that we have to do this, but I want to see what happens when we put this into the code editor here. A is either 1 or above 10. So because A is 1, if A is equal to 1 or A is greater than 10, so it's going to give us back that it is either 1 or above 10, right? Because that's true. All right. Now for the next one. And I guess we could get rid of this because we don't really need that anymore. So name is Bob. Hungry is true. Okay, let's see what happens. Bad input on line 3. What did we do wrong here? Ah, no. Bad input on line 3. Did I miss something? I don't know. Let's just put this on its own line. Let's see what happens here. Okay, yeah, it just needed to be on its own line. I figured that was probably the issue, but... Okay, so name is Bob, hungry is true. If name is equal to Bob and hungry is equal to true, print Bob is hungry. That both of those both of those are correct. So yeah, Bob is hungry. So, all right, pretty cool. And we caught a little bug there, you know, as well. I guess it's not really much of a bug, but I guess it's just more of a, you know, typo. So, all right, let's dig into some more stuff here. Introduction to if statements. Using if statements allows programs to make decisions. They let a program choose a decision based on a condition. Below is an example of how an if statement can be used to determine the section of code which print statement to use. If age is less than 17, print you are not old enough to drive. Else, print you are old enough to drive. In the example, if you are younger than 17, the program will output the text, you are not old enough to drive. However, if you are over the age of 17, the program will output, you are old enough to drive. Makes sense. Pretty basic logic there. Depending on a condition, in this example, it's the age variable. The program will run different code sections. There are some key components we note from our code example above. The if keyword indicates the beginning of the if statement followed by a set of conditions. The if statement is only run if the condition or sets of a condition is true. In our example, it's age 17. If that condition is true, age is below 17, the code within the statement runs. Per the example, if certain conditions are not met, the program can default to running code shown in the else part of the if statement. A colon marks the end of the if statement. Note the indentation. Anything after the colon that is indented is considered part of the if statement which the program will execute. They're talking about right here. So this colon here, it needs to be nested underneath of that for it to make it part of that loop. So this is the basic logic, right? Which we just kind of discussed. Kind of makes total sense. It's a pretty basic logic. Is driver younger than 17? Yes. You are not old enough to drive. Stop. No, you are old enough to drive, stop, right? So basic if this, then that, if else, you know, loop. So in this exercise, we will code a small application that calculates and outputs the shopping cost for a customer based on how much they've spent. In the code editor, click on the shipping.py tab and follow the instructions to complete this task. Okay, cool, completed. Once you've written the application in the code editor's shipping.py tab, a flag will appear, which is the answer to this question. This project, you'll create a program that calculates the total cost of customer shopping basket, including shipping. Shipping, oh my goodness. If a customer spends over $100, they get free shipping. If a customer spends less than $100, the shipping cost is $1.20 per kilogram of the basket's weight. Print the customer's total basket cost, including shipping, to complete this exercise. Okay, so let's think through this. If the customer spends over $100, they get free shipping. So if I guess we probably want to create a variable here for starters. If customer, let's go back here. Customer spend is greater than 100. We'll put our variables up here. Customer spend okay. Customer spend is greater than 100. Print customer basket cost right? Okay. Because why? Because it's only concerned with the total basket cost, including the shipping. So else print customer. We need to know that the basket weight is $1.20 per kilogram. Right? Okay, let's test it out. $52.8. Let's see if we set this to 100. Let's see if we get that. Oh wait, I guess we don't need to do that. If customer basket cost is greater than 100, spends less than 100. Okay, let me think here. If the customer basket cost is less than 100, customer basket cost plus the $20. Right, because if the customer basket cost is less than 100, then print the customer basket cost plus the customer basket weight, else print customer basket cost. I think that's what we want. Yeah, okay, we got it right. So you can see there, sometimes things take a little bit of time to figure out in your head, and that's fine. You know, that's probably very simple logic what I just did there. You know, you can see how rusty I am, but it's okay to be rusty. It's okay to, you know, sharpen those gears up in your head a little bit, make it all work the way that it's supposed to. These things come and they go, and you have to sometimes refresh yourself, and that's part of cybersecurity. And that is what will make you a great cybersecurity professional and separate you from, there's that statement of the wheat from the chaff, right? So you get to be separated, the wheat from the chaff. And shipping.py on line 12, when using the code editor's hint, change the customer's basket cost variable to 101 and rerun your code. Okay, and we do my first app, and yeah, because it is greater than, so it runs the else. The customer basket cost is now just the only thing that's printed. So okay, all right, well, I think that's it for me for tonight, and I appreciate you riding along with me here for a little bit. In the next video, I'll be going through tasks 7, 8, 9, and 10, finishing up this and moving on to the next Python series. And then we'll continue this shift from blue team to red team and see where it takes us. So thanks for riding along with me on this journey, and I look forward to more video content coming your way soon.